Hey everyone, in a previous video we talked about two force members. Today we're going to talk about three force members, and they're really very similar. There are special characteristics that are kind of cool, and I really like them actually better. You don't need to use three force member rules in order to solve problems. You can do it by equilibrium, and we actually are going to do that here with a problem that we've already done. But I find the characteristic of three force members to be really fascinating. So assume you have some sort of a physical object. In this case, we got a beam, and you've seen this before, right? So I've got a linear beam, horizontal beam, and it's attached to a roller over here on the right, by a pin over here in the middle, and then by a spring over here on the left. That doesn't need to be a simple looking linear beam like this. There's some really interesting problems out there. But this is going to be true of any object that has only three forces acting on it. Oftentimes one of those forces is the weight of the object. But doesn't matter as long as there's only three forces acting. And so here's our beam. There are three forces acting on it. Now what's interesting about this problem, and again we did some of the forces, some of the moments earlier on, but what we find is that this force is a normal force, right? Because it's a roller, so there's a normal force. But what I'm going to do with the three force member is I extend the line of action of the force. All right? And then I take a look at the tension over here. So the tension is in this direction. And then again, extend the line of action. And those two lines of action will always intersect at a single point right here. And what that tells me is that the sum of the moments about this point right here has to be equal to zero. Sum of the moments about any point in static equilibrium has to be equal to zero. But this point, life gets really easy, because if I do the sum of the moments about this point, the normal force here, what we called R for the roller in the previous video, that roller is going to have this line of action pass right through this point, right? It's not a middle point, but this point. So the moment, or the torque, by this roller is zero about this point. And then if I look at the tension has its line of action go through the same point. So the moment, due to the tension, T, acting around this point, is also zero. So these two forces apply no moment around here. Well, again, the sum of the moments, the sum of the torques around any point will always add up to zero when the system is in static equilibrium. So if that any point is this point, there are already two of them are zero. So the third one also has to be zero. And the only way that can happen is if the line of action for this third pin, remember we had px and py, but the line of action for that force has to go through here, or else it's not going to be a moment of zero. So I know by default the line of action for this pin is going to be that direction. Okay, so what have I got? I had it broken down into px and py before, but those were just components. It has to be in this direction so that the moment, or the torque, it exerts around this point right here, I'll call that C for like some center point, that's going to be equal to zero. That's the only way it can happen. So three force members are really cool. If you don't know the direction, you're going to be able to find it if you know the directions of two of the other three forces, because they all have to come down to this point C with their lines of action. And so you're going to have some information given. So that's a three force member. Four force members, beyond that, they're no more fun. Now you have to do the sum of the forces, sum of the moments, and you have to be given enough information to solve it. Three force members and two force members, they're just very cool and very fun to work with. All right. If you have any questions on that, put them in the comments below. Thank you.